Hello, dear students. I am Dr. Kapil Chaturvedi, as a professor in Department of Computer Science and Engineering, SIRT, Sage Group, Bhopal. In this lecture, we will discuss our topic, Introduction to Software Engineering. First of all, you have to understand what is software engineering. The formal definition of software engineering says that software engineering is an engineering approach on a software development of systematic application. If you have to develop one of the application or if you have to develop one of the software, then the major question is what kind of steps you have to follow, what kind of pages you have to follow, what kind of model you should adopt to develop a software. So all about information, how we can develop a software, a good software. Uh, you can easily understand and learn by the software engineering subject. A software engineer is a person who applies the principles of software engineering to design. A software engineer is a person who applies the principles of software engineering to design, develop, maintain, test, and evaluate computer software, as we discussed. So, to develop one of the application in the in software field, we must adopt one of the model to develop any kind of project. As per the project, we decide what kind of model or what model we should adopt to develop our project, or what model will be the suitable to develop our project. So in this slide, you can see here we are seeing one of the model uh, which elaborate the life cycle of a software development. Once we understand that life cycle, we will discuss the various mechanism of that based on that software SDLC process. So the phases of SDLC are planning, analysis, design, implementation, and maintenance. So in planning phase, we try to understand what are the needs of the customer. Also, we try to understand what is that project is feasible or not. It means we make a feasibility report of that project. Once we check that project is feasible, we will go on the analysis phase. We'll go on the analysis phase and analyze what is the process of to perform that kind of thing or to convert that kind of thing in the software. There we convert that analysis in design. In this phase, we develop data flow diagram, entity relationship diagram, that's ER diagram. We prepare Gantt chart to make our schedule. We prepare use case diagram, flow charts. So different kind of diagrams you will make to prepare a proper design of the software. Thereafter, we will come on the implementation phase in which we make the real-time code in any of the languages like C, C++, Java, Python, .NET, C#, or whatever language you can adopt to develop that design in the implementation phase. Once we implement that software and test properly and perform the post-implementation phase on the basis of the customer's requirement, we go on the maintenance phase. Parallel maintenance will go on once we deploy the project on the client side. So the maintenance will continue go on as the requirements will grow of the customer. The similar process is showing in that diagram, but the diagram represents the process which is in cycling way that is known as prototype modeling, where requirement analysis, design, implementation, testing, and after evaluation phase, customer may suggest more can ask for the more requirement or add-ons, new add-ons in the software. So the process will go on and repeatedly follow the process, requirement analysis, design, implementation, testing for the new module which we have to newly add in our portal. There are another SDLC phase is here we are just seeing the different diagrams, different view of representing SDLC. Like in this phase, we are representing planning, analysis, design, implementation, and maintenance uh, in a linear way. But here we are showing prototyping way. Here again a linear way to represent that SDLC: requirement analysis, design, implementation, verification, and maintenance. There are so much way to represent the SDLC steps in different diagrams. Now we are coming on the software models. On software models are the models which we will adopt, as we discussed in the earlier of this discussion, uh, where we implement when we implement one of the application. First of all, we decide what model we should be uh, be adopt to develop that kind of project. It means whether that project is a generic product or that software is a customized product. Generic product, it means once software developed, customer will use that. Customer will never ask for the modification. And in customized softwares, customer can demand for further modification in application in future. So software models are way of expressing a software design. Usually some sort of abstract language or pictures are used to express the software design. So what is this actually? So the first model is waterfall model. In this, you can see that first of all, each and every model follow the SDLC process. This thing is very clear, so we in our mind. Waterfall model says that first of all, we perform the analysis, then perform the design, then implementation, testing, deployment, and maintenance. So that steps are similar to the SDLC steps. What thing which we have to keep in mind? This is waterfall model, and as per the property of the waterfall, once we complete requirement, we'll go on the system design. Once we complete system design, we come on the implementation phase. Whenever we are working on the implementation phase, we will never go back to the design phase, and where we are working on the design phase, we will never go on the analysis. It means we must have to complete the one task and go on another task. We will try to not go back anyway, anytime. So this is waterfall model. Second model is rapid application development. In this, we can you can see that the many of the increment are go on parallelly. If the application development time is very less and we have to develop application very rapidly, very fastly in very small duration, then we divide that application in multiple module and will work in the multiple increment that to develop the rapid application. That the spiral model. Spiral model, it means we work for determine the objective, identify and resolve the risk, development and test the software, plan for next iteration. It means once we complete and deploy the software on the client side, and when we release the software, customer can demand for the further modifications or to further add-ons in software, and we repeatedly go on from the determine objective, identify, resolve risk, development, test, and that process will go on. So that spiral model says that in each and every phase, you must have to follow prototype 1, prototype 2, and operational prototype. Means in each phase, you have to follow some steps like HDLC. Whenever you are going for the risk analysis and uh, analysis phase, you will have to follow, identify the risk, recognize the need, analysis, design, implementation, and post-implementation phase. In each of the phase, you must have to follow each step again and again. So this is spiral model. The another important model is component-based software development model, which says and explains the logic of reusability, explains the concept of reusability, in which you can see that in the spiral model, we have some steps like planning, risk analysis, engineering and construction, customer evaluation, and customer communication. So we start from the customer communication and go on the planning, then study on the risk analysis. In engineering phase, we actually develop the software. So that model focuses on that engineering and construction phase, where you can see that whenever you have to develop any of the module in that engineering phase, first of all, you'll have to find out that module in the library. This is component box. First of all, you'll have to find out that component in the library, look up component in the library. So you are finding out that component in the library. If that component is available in library, then extract that component, then build component if unavailable. If it is that component which we have to develop is not available in the library, we'll develop a new component and put new component in the library. We'll add that component in the library and construct another iteration of system. We will add that component in the our software or our module, and we'll go on in another iteration continuously till we complete our construction of modules. So that model explains the concept of reusability. Uh, we can reuse our component uh, by adding the library and by by fetching from library. So this complete presentation, this complete video lecture will explain you the SDLC steps and the fundamental concept of software engineering, as well the basic models of software engineering, like waterfall model, spiral model, and component based model. So we'll continue the topics in the next lecture. Thank you.